fall in blood volume and blood pressure stimulates renin secretion from the juxtaglomerular cells of the kidneys. A fall in blood volume and blood pressure stimulates renin secretion from the kidneys also through the baroreceptor reflex and renal sympathetic nerves. Renin enters the blood, splits the plasma protein angiotensin II angiotensin I, which in the pulmonary circulation is converted to angiotensin II. Angiotensin II, on reaching the adrenal cortex, stimulates the Zona glomerulosa cells to secrete a mineralocorticoid hormone called aldosterone. Plasma potassium levels, when higher than normal, also directly stimulates the adrenal cortex to secrete aldosterone. The hormone aldosterone enters the circulation and on reaching the kidneys, acts on the cells lining the collecting ducts. Being a steroid hormone, aldosterone enters the collecting duct cells and acts on gene expression, which activates sodium transport proteins. At the luminal border of the cells bathing the tubular fluid, the four arrows represent aldosterone actions. First, sodium ions enter the cell through epithelial sodium channels, setting up an osmotic gradient which draws water into the cell. Remember, water follows wherever sodium goes. And for each sodium ion entering the cell, either one potassium ion or one hydrogen ion moves out into the tubular fluid, and got excreted in the urine. Now, what are the effects of the four arrows or four actions of aldosterone? First, sodium ions that have entered the cell activate the sodium-potassium pump in the basolateral border. The pump transports sodium out of the cell into the interstitial fluid. Sodium ions then diffuse into the blood of the peritubular capillaries. Again, water follows sodium. Sodium and water in the blood plasma maintains the blood volume and blood pressure. Remember, sodium forms the backbone of the extracellular fluid volume, including the blood volume. And the blood volume is one of the determinants of blood pressure. Higher than normal plasma levels of potassium directly stimulates the adrenal cortex to secrete aldosterone. Remember, aldosterone action results in secretion of potassium ions into the tubular fluid in exchange for sodium, until the plasma potassium levels fall back to normal. Understandably, the four actions of aldosterone and their respective effects will be exaggerated when aldosterone levels are constantly higher than normal, such as in the case of tumors of the adrenal cortex. For example, Conn's syndrome. Sodium retention in the blood results in increased blood volume and higher than normal blood pressure called hypertension. Increased loss of potassium into the tubular fluid and its subsequent loss in the urine results in low plasma potassium levels or hyperkalemia. Increased hydrogen ion secretion into the tubular fluid causes lower than normal plasma hydrogen ion concentration and metabolic alkalosis. Such effects occur when aldosterone actions of the 4-ROs are massive and prolonged. When the aldosterone secretion is lower than normal, as in Addison's disease where hormone-secreting cells of the adrenal cortex are destroyed, the 4 actions of the 4-ROs of aldosterone became attenuated, resulting in the effects opposite to the seen in hyperaldosteronism. So remember the 4-ROs when it comes to the role of this important mineralocorticoid in the regulation of blood volume and plasma electrolytes, sodium and potassium. That's all for now.